Okay, welcome everyone to the Aarna Networks webinar series. Today we're going to be discussing the ORAN opportunity, advanced features and use cases. A few housekeeping notes. While the webinar is in progress, we encourage you to use the Q&A box to send us your questions on the content. We'll be collecting those and going through a Q&A at the end of the webinar. Everyone that has registered for this webinar will also be sent the materials after the webinar is complete, a recording of the webinar, and also a link to the slide deck that we go through today. So without further ado, I would like to introduce our panelists. Next slide, please. All right, we've got three experts from Aarna Networks on the call here today. Yogendra Pal, a software engineer. Also Pavan Samudrala, senior member of technical staff. And Bhanu Chandra, also a senior member of technical staff. Welcome, gentlemen. The first speaker here today is Yogen. So I will pass things over to him. Next slide, Priya. Okay, Yogen, you can come off mute.
Okay, can you hear me?
Yes.
Okay, as all understand that this is the webinar where we want to talk about the advanced features and the use cases of the ORAN. So we thought we can start with some high-level overview of the ORAN architecture and what are the various components involved in, and then in subsequent slides, my fellow colleagues will be zooming into the advanced use cases, and then take it forward from there. And so without wasting much time on that, so I want to touch base what are the various components involved in the ORAN architecture. So the orange ones, what you see in this architecture drawing, are the components which are coming from the ORAN specs or ORAN architecture or ORAN Alliance group. And the ones which you see in the blue blocks are coming from 3GPP specifications or 3GPP standard bodies. Right. So to touch base on each of them, like how you do any deployments, right? You need a platform or a network architecture to be laid down, right? So keeping that as in mind, right? So the O cloud is the fundamental base here, where we are expecting the various disintegrated RAN elements are going to come and sit in, right? So that is a necessity of the O cloud in the drawing in the architecture, which is what is shown there, and that is managed through the an SMO component, which is your service management and orchestration. Essentially, what it's going to do is it's going to do the bringing up of their infrastructure. Meaning, if you wanted your a disintegrated DU or CU, or the control plane of the CU or the user plane of the CU itself to go and reside in some distributed clouds, right? So then essentially someone has to oversee the whole network and then decide where it has to go and sit in. So SMO is the one who is doing that role using the standard interface defined by the ORAN, which is your O2, right? So that's the necessity of why O cloud and the SMO has to go hand in hand there, right? And then so essentially the SMO also has an interfaces to various RAN elements, because as it's the central entity to look the whole network in, right? So yeah, so it can actually decide which network elements has to connect with which network element in the RAN, and then what is the interfaces which needs to be provisioned for doing your various FCAP operation, whether it is it has to go to the DU or it has to go to the radio element, right? So that's the necessity of it, and that actually is being dictated very well through the O1 interface, which is another interface for doing the configuration management for the for DU and for the control plane and also for the radio unit. But radio unit essentially doesn't go as like O1, but essentially there is another abstraction layer, which is think of like an M plane interface, which is essentially using the O1 in some manners, right? So if you can see that each of these interfaces has an FCAPS defined in, and SMO is responsible for doing all the management of that, right? And then you will see that SMO has a component of, basically it's called non-real-time rig component, which is the main abstraction of all the logic which traditional RAN used to have it in a traditional deployment, like in 4G or the previous generation of it, right? So that all has been abstracted out and has been divided into two entities. One is non-real time, and other one is a near real time, right? And what they have done is the ORAN has essentially placed the near real time rig closer to your control plane and the distributed unit of the RAN. And what they've done is the ones which are intensive to the compute in terms of the processing, that has been pushed to the non-real time component, non-real time rig, and that is what is been the part of the SMO, right? So each of these brings in a different use cases and capabilities which can be used to build specific advanced use cases and the features. And so with that, I would like to not go deep into this whole architecture, but I would bridge it to the next slide, where what we want to talk through is more of how this overall architecture has been done and interop with the various vendors. And from there, we'll take it forward to the zooming into the non-RT rig and the various RAPs and what are the various use cases involved in there. Okay. Shall we take to the next slide and pass it to the Pavan to take forward?
Yes. Okay, Pavan, go ahead.
Hi everyone, this is Pavan. So today I'm going to talk about the ORAN Alliance, the CHIP Roma, ORAN Plexus, and I14Y Labs, and what are their purpose and how they are contributing to the goals of ORAN. So if you see here, the ORAN in this slide, we have mentioned about the goals and key objectives of ORAN Alliance and the Linux Foundation. So when I said ORAN Alliance and Linux Foundation, I'm specifically targeting about the ORAN SC community. Here, if you see the goals, like, of ORAN SC communities, primarily to demonstrate the capabilities. Okay, so if you already know that, okay, the ORAN Alliance, the goal of the ORAN Alliance is basically it has got several subgroups, and each subgroup is responsible to come up with, like, specifications, and those specifications will have further details about specs and architectures, right? So once those things are defined by the ORAN Alliance, like, the ORAN SC's responsibility is to pick up those specs and architectures from the defined by the ORAN Alliance, and then they convert them into the software. Okay, so once they're converted into the software, basically, like, it can be used to demonstrate the capabilities of ORAN Alliance specs, which are talking about. Okay, and the other aspects which the ORAN Alliance is our ORAN software community goal is basically collaboration, to support the collaboration. So when I said support the collaboration, like, there are so many other groups which are complementing the ORAN SC and ORAN Alliance. Like, for example, TIP is one, ONAP, there are many other groups, and each one complements the entire ORAN goal in different ways. I will cover them in the subsequent slides. Okay, let me move to the other goal, which is, like, basically to come up with, like, the development of the non-RT rig and near RT rig, and then demonstrate those capabilities across different projects. So primarily, these are the key goals of the ORAN software community. And as I mentioned in the slide, like, this is kind of the de facto largest community-based project. Okay, so can we move to the next slide, please? Okay, so here specifically I talk about in this slide about CHIP Roma 2.0. So I mean, the first question is, like, there is a notion in the industry that, like, what is a goal? What is the difference between ORAN SC and CHIP Roma or TIP? Okay, or the ORAN Plexus, which are conducted by the ORAN Alliance. What are the goals? Do they complement each other, or they have, like, effort duplicated across different groups? So to answer the question with the short answer for that question is basically they complement each other. There is no duplicate effort at all across all these groups. Okay, no matter you take ORAN as a software community where it comes up with the implementation of the architecture and the specs defined by the ORAN Alliance. And if you see the tip, okay, where the goal of the tip is basically to deliver the ORAN disaggregated compliance, okay, testing, in fact, okay, it's one of the primary goals. So for that, tip Roma is subgroup of tip, where the goal of this tip Roma is basically to see how different disaggregated ORAN components can be managed by a single SMO solution, which is compliant with the O1 spec. Okay, that's the primary goal. So to achieve that goal, what tip Roma community did is basically they have, for all the disaggregated ORAN components, starting from SMO, CU, DU, RU, I mean, all components, they have come up with the requirements. How did they come up with the requirements? What they did is they invited multiple telecom operators into the group. So primarily this tip Roma group consists of multiple telecom operators who basically provide the feedback and inputs about what is exactly they need, how the SMO should solve their real-time problems, right? So from the feedback from different telecom vendors, the tip Roma has come up with the requirements. When I said requirements, basically you can consider those requirements as broader level, okay, where they fall into multiple categories, it could be CU, DU, RU, okay, or near non-arteritic or near arteritic, okay. So they don't talk specifically about which component, but the requirements are very generic and very broader. And from those requirements, which are derived from the inputs from telecom vendors, so tip Roma community has come up with the test cases. Okay, the test cases purpose is basically to solve the requirement, okay, to satisfy the requirement. Okay, so now once the tip Roma defines the requirements and test cases, the next job is basically any ORAN vendor can come on board, whoever is offering a CU, DU, or RU or SMO solution, okay, and compliant with O1 and X, can group together and start doing the interoperability test. So that once the interoperability testing is done, the set of test cases defined by the Roma community are satisfied, okay, so then they are eligible, or they can publish the results in the tip Roma group so that it will be available for the telecom vendors. And the whole goal of ORAN is basically the telecom vendors should have a choice to pick and choose from different vendors, right? So from these results, each telecom vendor can take an informed decision about hey, this solution solves me this problem, okay, so I can pick this, okay, and this SMO solution from this specific vendor solves the problem and it is compliant with O1 and it has support for all the FCAPs, etc. So that informed decision can be made by the different telecom vendors to pick and choose the ORAN components in their end-to-end solution, end-to-end 5G solution. Okay, so and basically the requirements also calls for, when I said requirements, today may not be all SMO vendors or ORAN component vendors has got the capabilities to satisfy all the requirements. So that also gives guidance for the product development for different vendors. Okay, so that's also one of the primary goals for Roma, because the requirements are directly comes from the feedback from the telecom vendors. So it is kind of a direct feedback for the product to support. So that's primary goal of tip Roma, and tip Roma has also got coming up in the next month. They are announcing a badging process, in the sense it's not only just the requirements. See, not every ORAN vendor or SMO solution provider can satisfy 100% of the requirements. So they are coming up with a criteria about different levels of badges. So based on different scores, based on the different requirements which are being satisfied by the solutions, by successfully executing the test cases, the appropriate badge will be issued to the each vendor. So that will also help the telecom vendors who wanted to pick and choose different ORAN solutions. Okay, so to go over hey, this vendor is having this badge, so that gives them confidence about what kind of offering he can do. Can we move to the next slide, please? Okay, so apart from TIPROMA, there is something called as I14Y lab. Okay, this I14Y stands for interoperability. So this is also a platform, okay, where multiple vendors, okay, come together and start doing the testing of their ORAN solution. So this I14Y lab is kind of hosted by ORAN, basically. So if you see every year ORAN, community conducts like, PlugFest. Okay. So for example, the last year, 2022 PlugFest. Okay. So we were part of the PlugFest and we did a lot of interoperability testing with the different vendors. Okay. Because Aarna offers SMO solution. So the SMO solution is kind of tested with different ORAN compliant vendors who brought in their CU, DU, and RU. Okay, so and that way, like, any system integrators, like, for example, the telecom vendors usually approach the system integrators to come up with the end-to-end 5G solution, right? So during that, like, the system integrators who are part of this I14Y lab does this interoperability testing, and by the time the telecom vendors approach the system integrators for the solution, they can provide the recommendations about, okay, this SMO solution has got these capabilities, and this RU vendor is compatible with this SMO solution. So this is again the platform for doing the interoperability testing and come up and basically demonstrate the capabilities. Okay. So as I mentioned in the slide, like, last year we did this interoperability testing with the Capgemini Engineering, who brought in their CU and DU, and a different vendor who brought in their RU, which is Foxconn. So that way the capabilities are demonstrated and the requirements basically stand similar to the TIPROMA requirements, wherein, like, the capabilities of multiple O1 and M-plane requirements are evaluated, and then that can act as an input to the telecom vendors. Okay, and as I mentioned in this slide, okay, some of the use cases, very basic use cases are like, which I highlighted here, like for example, how does the once the infrastructure is up, how does the GNOV network service gets orchestrated using the SMO? Okay, so that orchestration capability has been demonstrated using the O2 interface of Aarna's SMO. And the other thing is, like, other use cases, like, how once the network service is orchestrated, how does the network service monitoring be done? Okay, that's also demonstrated using the O2 interface of Aarna's SMO. And then other thing is, like, the data path validation is also being done. So when I said data path validation, so basically making a call over the 5G is what the data path validation. Okay, and once the data path is validated, like, next thing is, like, how does the orchestrated network service gets its life cycle managed? Let it be, like, upgrades. Okay, so let it be, like, scale out. Those capabilities are also demonstrated as part of the PlugFest 2022. Yeah, that's it from my end. With this, I will hand it over to my colleague Bhanu.
Yeah, hi everyone. This is Bhanu. So yeah, before we are jumping into the use cases, I just wanted to touch up on a high level on the non-arteric and the RAPs. So, and after that, the related use case will be discussed. So yeah, first one is the non-arteric. So as my colleague explained in the previous slide, so non-arteric, which is part of the SMO, and it has the termination of the A1 interface, where it will interact with the near arteric, and it will do all the policy guidance, enrichment information, and AML models via A1 interface to the near arteric. Whereas it also exposes R1 services to the RAPs. So that's brief about the non-arteric part. Let's discuss the RAPs. So RAPs are primarily a value-added services, and these are meant for the RAN optimization and efficient radio resource management. And it can be a AML model or any application. So our apps will interact with the SMO/non-arteric via R1 interface. So where R1 interface is primarily defines the standards like how our apps has to be written. So as the entire ORAN is about the disaggregation, so vendors can write their own R apps, but in order to deploy their R app in ORAN architecture, they have to follow the standards of the R1. So which are essentially like what is authentication, what is authorization, how our apps going to access the data of the SMO, all the O1 related metrics and front hall M-plane related metrics. So those are all well defined in R1 interface, and our apps has to follow those standards. So that's about the R apps part. Next slide, please. Okay, so with the help of the R apps, we can solve various use cases. Some of the use cases are listed here, like so I have listed on the 6 use cases here, but out of these 6, we will discuss more on the first 2 use cases, traffic steering and the QoE in the next slides, but I will touch upon a high level on what each use case is about. Traffic steering use case, this is mainly meant for the traffic in a balanced distribution across all the cells. So let us say if there is a number of, let's take an example, like if we need serve more number of users, then we need to install one more cell. So that is one way of scale out. But instead of that, if we efficiently reuse the existing and balance the traffic such that then RAN optimization, we can use it full potential. This is just one example of the traffic steering use case, but there can be many more. The idea here is to efficiently use the RAN and radio resource management. That's about the traffic steering. And the QoE, this is mainly meant for the high intensive bandwidth applications like AR, VR. And here, these applications primarily needs the low latency, and in order to serve those, the network has to be follow the corresponding QoE measurements. So, and coming to the next one, QoS. QoS is mainly meant for the, we need to give a preferential to the certain users. So in such cases, we use the QoS services. Let us take an example like, let us say, emergency situation. In that case, we need to give a preference to whoever dealing with the emergency services. So, and for the others, it's okay to cut down the bandwidth, but we need to have a high preference to the emergency services. This is just one example. So all those comes under the QoS related optimization and context-based handover for the VTX. This is mainly for the vehicular communication. And in most of these autonomous cars and vehicular communications, these UEs, which are nothing but the cars or any entity, can send the data to the VTX servers. The servers has to respond pretty quickly, and also the handovers happens. Here it has to be pretty quick. So it should not cause any anomalies. So there are certain applications which improves the performance of that and detects the latency and all. So that is for the VTX related improvements. And the next one is the RAN slice SLA assurance. So with the 5G, there is a lot of push on the slicing, and each slice will be having its own data rate and capacity and the latency and all. But and also we need to ensure that the given SLAs has to be maintained throughout, right from the RAN, core, and all the involving parties. So RAN slice assurance use case, it involves like it constantly monitors, and if any changes required, and it will push those. So some of the R apps deals with this RAN slice SLA assurance. And the other one is like MIMO optimization use case. So in order to optimize the MIMO, currently the only way is like beamforming. Even with the beamforming also, there are certain challenges there, like cell interference and the neighboring cells, all the signals. So the idea here is like there are certain R apps which are coming up with AML models, so which efficiently configures the beamforming so that it distributes the traffic and the cell geometries and the mobilities. That's the high level information, all the use cases. Next slide, please. So the traffic steering we will discuss more in detail. So currently the operators needs a way to optimize or define the configuration policies such that it satisfies a certain performance criteria, and it can leverage certain AML models for that. And ultimately the end goal is it distributes the traffic in a balanced way, and also react to network prediction and the UE performance. Next slide, please. So in order to achieve the traffic steering, it's not possible via one single application or the AML model. So when we deploy in the production, it has to have we need to break it down into multiple either ML models or the applications, and some of the application models are what we are going to discuss here. So the first one is the cellular load prediction. So one way is like how exactly the cell is being loaded, and the other way is like how the user traffic volume prediction. Based on the prediction, either we can push the new users to the another cell, or we can retain in the same. So that decisions can be taken. And other one is like we'll generate a A1 policies to steer the traffic of certain users to another cell. And some of the time series predictions based on the metrics and counters what we collect from the O1 interface. And while doing this, right, it's not only for the single cell, we need to do it for the neighboring cells as well. And at the end, we will compare the load across the various cells, and the model will take a decision. So what are the models which we have discussed so far right here? So it can be any model, either it can be supervised learning, unsupervised learning, or the CNN. It can be any. It's not limited. In order to deploy all these models, so as an R apps, so it needs the data. So here we have listed down some of the data which these models might require, like load redirect metrics like uplink and the downlink, and the PRB occupation, which is physical resource occupation, and what kind of user traffic it is, and the counters, and some of the KPIs which are already defined, and measurement reports of the serving cell and also the neighboring cells, and some of the U-related metrics, and cell load statistics. These are mainly coming from the E2 nodes, and per user performance statistics. So the data what we get is the performance data, but that has to be processed further. It will be per cell and per user and the various other metrics. It will be converted, and that will be fed into the model to get the output of that. Next slide, please. Okay. So this is one of the example of like how exactly the flow is going to remain. So if you see the O1 data collection part, this remains same for all the use cases. So all the R apps needs the data. So that is what this O1 data collection does here. And once the data is being collected, if you see the step number 9 here, which is decision of optimization action, it evaluates R apps will monitors all the performance data, and let us assume it has taken a decision like step number 10 here, which is traffic steering policy create message. Our app will push it to a near arteric, and near arteric the step number 11, which in turn pushes to the E2 nodes. And once that is being pushed, this non-arteric R app, which continuously monitors the performance data, and finally, if the performance is under control, then it will take a decision to remove the policy, which is the step number 4. So whatever we have seen here from 9 to 14, which are related to the A1 policies, and the similar way which we can achieve with the A1 enrichment information as well. That is what is being shown in the next one, where step number 18 and 19, mainly near arteric will subscribe to the information on the enrichment information on the non-arteric, and as and when the information is available on the step number 19, it sends the information to the near arteric. The same information will be propagated to the E2 nodes, and the subsequent one from the 21 to 28, like it continuously monitors that. If it requires any update, that update will be sent to the near arteric, and near arteric will propagate to the E2 nodes. That is the whole flow. So we have seen the two ways here. One is A1 policies, and next one is A1 enrichment information. Next slide, please. Right. So here are some of the traffic steering sample policies. So if you see the leftmost one, this is one of the cell related policy where let us assume the cell ID, which is showing X here. So just for an example, we can take the cells which are listed on is A, B, C, D. Out of that, the first statement, it shows here avoid A and B for the MBB, which is mobile broadband, and prefer C and D cells for this particular UGID. So that is the cell related policy. And moving on to the next one, the right one. So this is the traffic distribution policy, where for a given UUID, the cell A has to serve up to 50 to 70%. So these are some of the sample policies, and all these samples, right? So is defined in data types of the ORAN specification. So we need to set the policy type ID, which is ORAN traffic steering preference. We need to set the version, and all this JSON schema should be as per the specification here. So, next slide, please. So this is about the QoE use case. So the main focus of the QoE use case is the 5G native applications and traffic sensitive and highly interactive applications like cloud, AR, VR. And here it's a, so the idea here is like application level. If we measure the QoEs at the application level, then it will be, we can efficiently manage the radio resources. That's the whole intention here. So we will get the various traffic related data and QoE measurements and the network measurements, and that will be fed into the AML algorithms, and which in turn analyzes how exactly the application is performing. Is it satisfying the needs of the QoE or not? And if not, we can enforce certain policies to achieve the required QoE. Next slide, please. So, so for the QoE, so the various models are listed down here. QoE prediction model, this tells whether the particular application is within the QoE limits or not. So it will tell us, that means it can be a video quality or whatever. So that is a QoE prediction model, and the QoE policy model, and available bandwidth prediction model. So how much is the bandwidth is available? This model can predict it. So all these can be AML models, and these models again requires the data. So the kind of data it requires is like network level measurements, like radio and mobility and metrics, and traffic patterns, like what is the throughput of that, and what is the latency, and what is the packets per second, and RAN related and cell level metrics. It needs the data of all the traffic related, right from the RAN, cell, and everywhere. And if SMO derives any of the QoE related metrics, that will also can act as input data. With all this, and these models will give the prediction. Next slide, please. Right. In this slide, so the flow shows like how exactly the QoE optimizations is in place. So again, data retrieval, which is common across all use cases. So here, the first one, which is via A1 policies. So with the available data, it continuously monitors the performance. And let us assume like if it doesn't satisfy a certain QoE optimization, then it will send a message to the near arteric for QoE optimization policy, and near arteric will in turn pass on that information to the E2 node for the QoE enforcement. And once that is completed, and it will send the policy feedback message, and non-arteric, the respective RApps will continuously monitors that, and if it satisfies the need, and it will update the A1 policy here. The flow is very much similar to the any A1 related policy. So it continuously collect, monitor, and update. Next slide, please. Right. Here are the couple of samples for the QoE related policies. So the first one, which is the leftmost, is about UG optimization policy. For let us take this EUID 101. So the requirements are like initial buffering has to be 2 seconds, and reverberation frequency is 2 times, and stalling ratio is 5%. So it has to, these are all the QoE objectives for this particular given UUID. Moving on to the next one, the right one. This is a slice level optimization policy, where we will give all the slice level details here. What is the SST, SD, and the PLM and ID? For that, the QoE score has to be 5. Again, the policy type ID, all these are as per the type definitions of the ORAN specification. All the JSON fields, whatever we show here, those are as per the type definitions. So policy type ID for this is like ORAN underscore QoE ID TSP 2.2. Yeah, next slide, please. So far in those 2 use cases, we discussed about the some of the models, but any of the AML model, so it has its own life cycle, right? So this is not specific to ORAN, but in general, if you want to deploy any AML model, it has to surpass all. Like we will just try to map it with the ORAN deployment. If you see from the leftmost, the number 1, which is like data. The data is like it generates the data OU, ODU, OCU, or the ORU. These are the data generators, like from which we will get the data, all the PM metrics, and that will be collected by the SMO, so which is the data collection. And once the data gets collected, so that goes to the data preparation part here where the data cleansing will happen. And once the data cleaning happens, and that will go to the AML model training. We will train the AML models with the training. And once the model gets trained, and it will be deployed onto the AML model management. So where all the various model versions will be maintained. And that is step number 4. And after that, the step number 5, which is like AML inference host, where it deploys the particular model and it checks. Let us say the step number 3 and 4 are like, if it's then the process is going to happen. But if it's offline, it can be offline training as well in such cases. So after the data preparation, it will directly come to the step number 5 here, and AML interference no host will gives the action. That action can be either config management on the CU or the DU, or it can be a generation of the policy or the intent that will go to the neuroteric via A1 interface. So that's all. So this is how this is not specific to ORAN, but in general, how exactly the AML model deployed, and we can map it to our ORAN AML model deployment as well. Yeah, that's all. Thank you.
Okay, next slide. All right, thank you for that, Yogen, Pavan, and Bhanu. The last slide here is a preview of our next ORAN webinar happening a week from today at this same time, where Sriram Rapanagunta and myself, Brandon Wick, will get into the business advantages of using ORAN. You can register in the link provided in the slides, and I'll also put a link out in the email that goes back to everyone who's registered here for this webinar. Okay, next slide. So let's shift into a Q&A. We've gotten some questions in already via the Q&A box, but I would like to remind folks, if you want us to consider your question, please add those into the box now, and we'll get through as many of those questions as we can in the next 10 minutes or so. The first question coming in is around the AI ML models. The slide that we were just looking at there towards the end talked about the models. The question is, do we foresee the models being developed by the community? I think this is very difficult due to lack of publicly available data sets. So to our panelists, what are your thoughts on that?
So let me take this question, Brandon. So in ORAN, there is a working group, which works on the AML, which is, the recent addition for quite some time. But in order to make the model develop, right, essentially, you need, various components to be up and running, like the SMO is coming up, right, and the O2 interface is coming up, the A1 interface is maturing, R1 interface is getting mature, right? So independently, someone can actually build the AIML model, but to ingress the data, right, which these RAN elements has to generate, right, that adoption has not come to a full pace. So essentially, I see that it is a slightly long goal, but I believe community is working on it. But which model exactly, that I don't have the answer at this point of time. But I'm looking forward that AIML working group is going to create something out of the current state of art.
Okay, thanks, Yogen. This next question is around the ORAN architecture drawing or diagram that you showed at the beginning. What are the various RAN elements coming from 3GPP?
Okay, so from the ORAN architecture perspective, right? So it's a mix of both, like it comes from ORAN as well as from 3GPP. Specifically from 3GPP, you have the radio unit, you have the distributed unit, and the control plane and the data plane of the centralized unit, right? So these are the four plus the E node B, which is from the LTE, right? That is also is part of the coming from the 3GPP to the ORAN architecture. So these are the 5 elements which are coming in.
Okay, great. Next question's about the ORAN community. Does it include both telco public networks and companies building private networks?
Yeah, let me take up that question, Brandon. So I'm assuming when it's mentioned as kind of the question is about ORAN community. So I'm assuming it is ORAN Alliance. It's so actually the ORAN Alliance includes today more than 300 plus companies, different operators across the globe, different vendors, and then in fact so many research institutes, academic institutes also part of it. So the primary goal, I mean, even though it's started with 5 major companies, right? One is China Mobile, AT&T, Deutsche Telekom, Orange, and one more, NTT, yeah. So, but today it's kind of 300 plus companies, including operators and research institutes. Okay, so yeah, so to answer the question, yes, it is basically the group constitutes of both public network operators, telco operators, and also the private 5G network builders. Yes.
Okay, great. New question coming in. Is there an interaction with the NWDAF and the RIC platform today for more end-to-end use cases?
So let me take it up. So currently there is no interaction between the NWDAF and the RIC platform, but there are some interesting use cases which are going to come up that maybe fill the gap. But as per the standards right now, NWDAF is part of 5GC.
Okay. Next question might be for you, Bhanu, as well. Of these use cases presented today, which is the most mature?
So most matured one is traffic steering and RAN slice assurance. So these are the two most mature. That means community is working, and from my experience, I see a couple of deployments as well. That means still in the POC stages, but I have seen some of the demos as well for these two.
Okay. Another question, do you see the NFs support O1 interface these days? And the same question for E2 as well.
So basically the network function, NFs is nothing but a network function. So 5GC NFs are not being considered here, but O1 is primarily meant for the E2 nodes, right? So it mainly for the CU and the DU.
Yep.
Yes,
Yeah.
it's right. The thing is, like, currently O1 interface supports both CU and the DU, mainly for all the FCAPS operation. So one is one for the configuration management and software upgrade, and also on the other side, it will collect all the performance related metrics and fault data. Yes, currently SMO is primarily capable of collecting all this data from the E2 nodes via O1 interface.
Okay. What about the CU and DU vendors? Do they support these interfaces out of the box now, as far as you know?
Yes, that's true. So if someone says like the CU and the DU is ORAN compliant, then they have to support the own interface for sure. So in fact, we are working with our partners, right? So they are ORAN compliant, and we are Aarna's SMO. We were able to integrate with the SU and the DU.
Okay, gotcha. What about the RApp and XApp ecosystem? So are companies creating these for testing? And what needs to happen for more comprehensive testing of these?
Right. So basically, now XApps are primarily some more way closer to the E2 nodes, let us say CU and the DU, and it works out of near out a rake. And so currently what we have seen is like, in my experience, whoever is having the near out a rake, there this XApps will be deployed. So the model management of XApps is in a bigger picture, it has to come via SMO/non-out rig, but that is not happening right now. But in a long term, so all the AML model management of the XApps will come from the SMO. But the RApps model management, AML models deployment and all, it will be happening from the SMO itself. But this comprehensive testing, so yeah, it's still in the early stages, but probably it's going to take some more time.
Okay, so third-party RApps are workable with the Aarna's SMO. Is that right?
Right, as long as it the RApps follows the Auburn standards for the deployment, then it will work with our non-autoric platform.
Okay. What about ORAN performance versus closed RAN? Is it getting closer? I think they mean things like processing power, speed, latency, telemetry data, things of that sort. I don't know if there's any benchmarking type available that, ORAN is mapping against, but is it the common perception that ORAN is still working to match some of the performance from closed RAN systems?
Right, any numbers are not yet published, but definitely there are certain apps which are mainly to improve the RAN optimization in that aspect. But currently there is no benchmarks are published on this energy efficiency. But definitely there are certain use cases like better utilization of the RAN.
Mhm. Okay. Will the O1 interface be used as EMS for flaps? If yes, will SMO be that EMS layer?
I think is it flaps or FCAPs?
F caps, yeah, that was a typo.
Yeah. So yeah, then it's yes. So SMO. So in the ORAN terminology, it's SMO, but considering all the functionalities and the capabilities, it acts as a single EMS for the entire RAN.
Okay. You mentioned energy efficiency. So can ORAN improve energy efficiency for operators? If so, how?
Let me take up this question, Brandon. So, yes, actually, the ORAN has got the guidelines and the requirements for energy efficient product developments. Okay, so when I said energy efficient, basically they talk about several aspects of it, like starting from the SMO, starting from the RAN elements, CU, GU, RU, like, there are certain guidelines which the ORAN community calls out specifically, and that definitely helps in improving the energy efficiency for the operators in their end-to-end solution. So in fact, there are requirements when I set the guidelines by the ORAN community, alliance community. So it's basically those guidelines are kind of taken up seriously by the team, all those groups, to make sure they have requirements and which they call out as part of their compliance testing or interoperability testing. So they have specific requirements with respect to energy efficiency. So that's how the energy efficiency guidelines by the ORAN boils down to different groups and subgroups and turns into requirements, and those requirements has to be satisfied by the ORAN vendor.
Okay, well, that's all the time we have for now. I want to thank our great panelists for sharing their insights, and look for a follow-up email with this webinar presentation materials. Thank you all very much for your time today.
Thank you, everyone.
Thank you, everyone.